Welcome back to the Python Pandas tutorial series. In the last video, we learned what Pandas is, why it's so useful for data work, and how to get it installed and imported using import pandas as pd. If you missed that, I recommend checking it out first. Today we're diving into the first of Pandas' two core data structures, the series. By the end of this video, you'll understand what a series is, how to create one, and how to perform some basic operations on it. This is a fundamental building block for everything else we'll do in Pandas. So what is a Pandas series? Think of it simply as a one-dimensional array capable of holding data of any type: integers, strings, floating point numbers, Python objects, etc. The crucial difference from something like a standard Python list or a NumPy array is that a Pandas series has an associated index. This index acts like labels for your data points, so a series bundles together your data values in these labels. You can think of it like a single column in a spreadsheet, where you have the data itself and row numbers or labels beside it. Or like a specialized Python dictionary where the keys, the index, have an order. Let's see how to actually create a series. First, make sure you have pandas imported. The most common way is from a Python list. See? Pandas automatically created a default integer index starting from 0. The output clearly shows the index on the left and the data values on the right. It also tells us the dtype, data type, which is int64 here. We can also specify our own index labels when creating it. The index must be the same length as the data. Now our index consists of strings, A through E instead of integers. You can also create a series from a NumPy array, or from a Python dictionary, where Pandas uses the dictionary keys as the index and the values as the data. Finally, you can create a series from a single scalar value, but you must provide an index in this case, as Pandas needs to know how many times to repeat the value. Now that we have a series, let's look at some useful attributes. We'll use our series custom index for these examples. The .values attribute gives you the raw data as a NumPy array. .index gives you the index object itself. .dtype tells you the type of data stored, and .shape gives the dimensions as a tuple. You can also give your series and its index names, which is helpful for organization, especially when we get to data frames. How do we get specific data out of a series? We use the index. If you have custom labels like A, B, C, you can access elements like a dictionary. Using .loc is generally preferred for label-based access because it's explicit and less ambiguous. You can also access elements by their integer position, just like a list, starting from 0. The explicit way to do this is using .iloc. Why use .loc and .iloc? Sometimes your index might also be integers, and using just square brackets can be ambiguous. .loc always uses labels, and .iloc always uses integer positions. Slicing also works. With .loc, slicing using labels includes the end label. With .iloc, slicing using integer positions works like standard Python slicing, excluding the end position. One of the key strengths of Pandas, and NumPy which underlies it, is vectorization. This means operations are applied element-wise without needing to write explicit loops, which is both cleaner and faster. For example, you can perform arithmetic directly on the series. You can also apply mathematical functions, often using NumPy. You can even filter using Boolean conditions, which we'll cover in more detail later. Okay, let's recap. We learned that a Pandas series is a 1D labeled array. We saw how to create series from lists, dictionaries, and NumPy arrays, how to define custom indexes, and how to access key attributes like .values, .index, and .dtype. We also practiced accessing elements using label-based.loc and integer position-based.iloc, and saw the power of vectorized operations. The series is the foundation. In the next video, we're building directly on this knowledge to learn about the DataFrame, the 2D table structure that you'll likely use most often in Pandas. It's essentially a collection of series that share the same index. Make sure you practice creating and manipulating series yourself. Try creating them with different data types and indexes. If you found this useful, hit the like button and subscribe so you don't miss the next video on DataFrames. Thanks for watching and see you next time.